Good day everyone, welcome back to our discussion on the topic matrix. Today we will be using matrix to solve some simultaneous equation. Let us consider the simultaneous equation 3x plus 2y equals to 16 and x minus y equals to 2. Now from our understanding of matrix multiplication, this can be written in the form matrix 3 2 1 minus 1, that we are removing all the coefficients of x and y, multiplying matrix sy, which should be equals to matrix 16 2. Now separating the matrix, that is separating the individual matrix and giving them a value, that is a will be equals to matrix 3 2 1 and minus 1, s will be equals to our matrix sy, and b will be equals to matrix 16 2. Now by substitution we have as is equals to b. Now finding s our only unknown, we will be dividing both sides by a, and when we do that, s will be equals to a inverse b. Now this result gives us a method of solving simultaneous equation using matrix. Now for the solution to the question we are considering, we know that our inverse is equals to our adjoint over our determinant, and the adjoint of a will be equals to minus 1 minus 2 minus 1 3. Now to refresh our memory, when we are finding the adjoint of a 2 by 2 matrix, we switch the first and the last element and we change the sign in the second and the third element. So our adjoint in this case becomes minus 1 minus 2 minus 1 and 3. Now for our determinant of a to be equals to 3 times minus 1 minus in bracket 2 times 1, which should be equals to minus 3 minus 2, which is equals to minus 5. So now we've gotten our adjoint, we've gotten our determinant. So our inverse will be equals to 1 over our determinant, which is equals to minus 5. Matrix our adjoint minus 1 minus 2 minus 1 3. So therefore to now get s, we know that s is equals to a inverse b. So s will be equals to 1 over minus 5 matrix minus 1 minus 2 minus 1 3 multiplying b, which is matrix 16 2. Now we're going to be multiplying the two matrices first of all. When we do that, it becomes s will be equals to 1 over minus 5 multiplying the two matrices, it becomes minus 1 times 16 in brackets plus minus 2 times 2 in bracket. Our next element will be minus 1 times 16 in brackets plus 3 times 2 in brackets. So simplifying our bracket, s will be equals to 1 divided by minus 5 matrix minus 20 minus 10, and multiplying the matrix by 1 divided by minus 5, s will be equals to 4 2. Recall that s is equals to the matrix sy, so therefore s will be equals to 4 and y will be equals to 2. Now this is the way in which we solve simultaneous equation using matrix. We have another example that states that solve the simultaneous equation s plus 2y equals to 4, 3s minus 5y is equals to 1. Now putting this in matrix form, it becomes matrix 1 2 3 minus 5 multiplying matrix sy is equals to matrix 4 1, and splitting the matrix, let a be equals to matrix 1 2 3 minus 5, s be equals to matrix sy, and b be equals to matrix 4 1. And we know that by this logic, as will be equals to b, and dividing both sides by a, s will be equals to a inverse b. A inverse will be equals to 1 divided by the determinant of a, matrix minus 5 minus 2 minus 3 1, which is also the adjoint. So the determinant of a will be equals to 1 times minus 5 in bracket minus 2 times 3 in bracket, which will be equals to minus 5 minus 6, which is equals to minus 11. So therefore x will be equals to 1 divided by minus 11 matrix minus 5 minus 2 minus 3 1 matrix 4 1. Now multiplying both matrices, s will be equals to 1 divided by minus 11 matrix minus 5 times 4 in bracket plus minus 2 times 1 in bracket, and minus 3 times 4 in bracket plus 1 times 1 in bracket. So therefore s will be equals to 1 divided by minus 11 matrix minus 22 minus 11, and multiplying s will be equals to matrix 2 1. So s is equals to 2 and y is equals to 1. Our third example states that solve the simultaneous equation 5x plus 9y equals to minus 3 and 6x plus 2y equals to 2 using matrix format. Now for our solution, putting our equation in matrix form, it becomes matrix 5 9 6 2 multiplying sy, that is matrix sy, will be equals to matrix minus 3 and 2. Now splitting the matrix, we know that A or matrix A will be equals to 5 9 6 2, S will be equals to matrix sy, and B will be equals to matrix minus 3 and 2. AS will be equals to B, and dividing both sides by A, S will be equals to A inverse multiplying B. Now to get A inverse is equals to 1 divided by the determinant of A, matrix 2 minus 9 minus 6 5. And to get our determinant, it will be equals to 2 times 5 in bracket minus 9 times 6 in bracket, which should be equals to 10 minus 54, which is equals to minus 44. Now substituting and getting the value of S will be equals to 1 divided by minus 44, matrix 2 minus 9 minus 6 5, matrix minus 3 2. And multiplying the matrix, S will be equals to 1 divided by minus 44, matrix minus 6 minus 18, 18 plus 10. So S will be equals to 1 divided by minus 44, matrix minus 24, 28. And multiplying them, recall that S is equals to matrix sy, so it will be equals to matrix 24 divided by 44, matrix 28 divided by 44. So dividing, S will be equals to 6 over 11 and Y will be equals to minus 7 over 11. We have another question from UME that states that determine S plus Y if matrix 2 minus 3 minus 1 4 multiplying matrix sy is equals to matrix minus 1 8. This is simply the form in which we solve our simultaneous equation using matrix. So therefore, splitting the matrix, A will be equals to 2 minus 3 minus 1 4, X will be equals to matrix sy, and B will be equals to matrix minus 1 and 8. So AS will be equals to B, and dividing both sides by A, X will be equals to A inverse B. Getting our A inverse is equals to 1 divided by the determinant of A, matrix 4 3 1 2, and our determinant of A will be equals to 4 times 2 in bracket minus 3 times minus 1, which will be equals to 8 minus 3, which is equals to 5. So substituting, X will be equals to 1 over 5 matrix 4 3 1 2 matrix minus 1 8, and multiplying both matrices, S will be equals to 1 over 5 matrix 4 times minus 1 in bracket minus 3 times 8 in bracket 1 times minus 1 in bracket plus 2 times 8 in bracket. So simplifying our bracket, S will be equals to 1 over 5 matrix minus 4 plus 24 minus 1 plus 16. S will be equals to 1 over 5 matrix 20 15. And recall, S equals to matrix sy, which will be equals to 4 over 3. 20 divided by 5 is 4, and 15 divided by 5 is 3. So S is equals to 4 and Y is equals to 3. But our question asks for the value of S plus Y. So S plus Y will be equals to 4 plus 3, which is equals to 7. And our correct option is C. Here are some exercises for you to try your hands on at home. And for more insight on this topic, you can check out our Hidden Facts Further Mathematics textbook. You can get the hard copy in bookshops, or if you are interested in the soft copy, you can get it at the website on the bottom of your screen. Thank you.